Hi students, welcome back to our channel Smarter Everyday Over Learning. Dear students, we have been learning the topics from the chapter Organic Chemistry, some basic principles and techniques. Right, up to now, what are the topics completed, what we had studied, those everything, the details I'll provide for you in the description. You can go through them. In our previous session, Quantitative Analysis, I had started. In that quantitative analysis, estimation of carbon and hydrogen is completed, and about the estimation of nitrogen. In that nitrogen estimation, Duma's method and Kjeldahl method also, these two completed, including with the apparatus explanation. Right, in this session you are going to learn about estimation of halogens and estimation of sulfur also. In the estimation of halogens, you are going to learn about fluorine, chlorine, bromine, iodine. These are the halogens, that thing you know very well, and these two are basing upon the Carius method. You are going to learn in this session Carius method. Okay, in these two estimations, what is the Carius tube for the estimation of halogens, the complete experimental details, and how we can calculate the percentage of halogen and the sulfur also, I'm going to tell you in this session. Right, let's get into the class without doing any late. Estimation of halogens by Carius method. Here, what is the main principle involved in this? Let's see now. For suppose a known mass of the organic substance is heated with cumene nitric acid HNO3, fuming nitric acid, and a few crystals of silver nitrate in a sealed hard glass tube. Okay, about the length is 2 centimeters wide and 50 centimeters of long. This is only called as Carius tube. In a furnace, you have to take this entire equipment in a furnace. Let's see the diagram of this Carius tube for the estimation of halogens. Here I have drawn, okay, and here iron tube. This is outside iron tube. Then this is completely known as furnace. This is iron tube, and here is furnace. And Carius tube made up of hard glass. This is only known as, and inside the Carius tube, this is the Carius tube. Again, you have to take a small tube of, here is the small tube which is containing a known weight of organic compound. In this tube, organic compound, this known already, we know that. So known weight of the organic compound you have to take inside a small, just like a test tube. Okay, and here is the solution. Fuming HNO3 plus 0.5 grams of silver nitrate AgNO3. This is the entire apparatus to show the estimation of halogens. Under specific conditions, under the conditions carbon and hydrogen are oxidized to carbon dioxide. Carbon is oxidized into CO2 and hydrogen is H2O, and halogen is converted into silver halide AgX. Halogens are converted into silver halide. These are next. The precipitates of silver halide are filtered. Here, after completion of this reaction, the precipitate will form this precipitate of silver halide are filtered and washed and dried and weighed. Knowing the mass of the substance is taken and the mass of the precipitate is formed and the percentage of the halogen should be calculated. Mass of the substance what we have taken, that should be W grams, and the mass of the silver halide formed, that is X grams. Now 1 mole of silver halide contains 1 gram atoms of halogens. Here in the place of X you can take chlorine, bromine and iodine. Okay, that is 108 plus atomic mass of X. Atomic mass of these halogens, grams of AgX. Here X contain AgX contain X is equal to atomic mass of X, grams. Therefore X grams of silver halide, here AgX contain X is equal to atomic mass of X by 108 plus atomic mass of X into X grams. This is the mass of the halogen X present in the W grams of the substance. Now the formula of percentage of halogen in the compound is atomic mass of X by 108 plus atomic mass of X into small x into 100 by weight. Okay, thus for chlorine, let's see for chlorine, as the atomic mass of chlorine is 35.5 atomic mass unit, AMU. Now basing upon that formula, the percentage of chlorine in the compound should be 35.5 X by 108 plus 35.5 into 100 by W is equal to 35.5 X by 143.5 into 100 by W, or the percentage of chlorine is equal to 35.5 by 143.5 into mass of AgCl formed by mass of the substance what we have taken, then students mass of the substance into 100. Why? Because it is a calculation of percentage, 100 here. And for bromine, now for bromine, as atomic mass of bromine is 80 AMU. Now percentage of bromine in the compound should be 80X by 108 plus 80 into 100 by W is equal to 80X by 188 into 100 by W. Right. Okay. Now the percentage of bromine should be calculated by using this formula, 80 by 188 into mass of here AgBr. Mass of AgBr can be formed by mass of the substance what we have taken. mass of the substance into 100. Basing upon this, we need to calculate the total percentage of bromine. Now let's see for iodine. As the atomic mass of iodine 127 AMU. Now the percentage of iodine in the specific compound should be 127 by 108 plus 127 into 100 by W is equal to 127 by 235. Here X into 100 by W. Now the percentage of iodine is equal to 127 by 235 into mass of AgI formed by the mass of the substance what we have taken into 100. Mass of the substance. Okay students, these are the formulae for the calculation. Here is the calculation part, and from that percentage of halogen in the specific compound, this is the formula. Basing upon this, we calculated that for chlorine and for bromine and for iodine also. These are the formulae. Right. Now let's see the example. In Carius method of estimation of halogen, 0.15 grams of an organic compound gave 0.12 grams of AgBr, and find out the percentage of bromine in the compound. Here the mass of the substance we taken, that should be 0.15, and mass of AgBr formed, mass of AgBr is equal to 0.12. They have given in the question itself. Now 1 mole of AgBr, 1 mole of AgBr is equal to 1 gram atom of bromine, or 188 into 108 plus 88 grams of AgBr. Now finally 80 grams of bromine. Therefore 188 grams of AgBr contain the bromine is 80 grams. Right. And basing upon this 0.12 grams of AgBr will contain the bromine is 80 by 188 into 0.12 grams. But this much amount of bromine is present in 0.15 grams of the organic compound. Therefore, the percentage of bromine is 80 into 0.12 into 100 by 188 into 0.15. That should be 34.04. So this is the percentage of bromine. Okay students, this is about the calculation in the Carius method, the estimation of halogen. Here they have given the exact mass of the organic compound substance, and we have to calculate the percentage of bromine in this way. Now we shall go for the next one, estimation of sulfur by Carius method. Here the main principle is a known mass of the substance is heated with sodium peroxide or with fuming HNO3, fuming nitric acid, in a sealed tube. Sealed tube nothing but that is a Carius tube. Carbon and hydrogen oxidized into CO2 and H2O. This thing you know. while sulfur present in the compound is oxidized to sulfur dioxide SO2. Okay, SO2. Sulfuric acid. Actually, sulfur oxidized into this is the sulfur dioxide, but in this case, in this estimation of sulfur in this Carius method, sulfur is oxidized into sulfuric acid H2SO4, which is then precipitated as barium sulfate. It is again treated with barium sulfate by adding of barium chloride solution, BaCl2 solution. Okay, now let's see the chemical equations and what are the changes and what is the reaction for this. Carbon plus 2 moles of oxygen. This is from HNO3. Then we heated this. If we heat this, CO2 will be formed. Now here carbon is oxidized into CO2. Now hydrogen, 2 moles of hydrogen here, plus if you add oxygen, this hydrogen plus oxygen, this is also from HNO3. Okay, if you heat this and hydrogen is oxidized into H2O. Right, now in this next step, sulfur, to this sulfur if you add water with oxygen, 3 moles of oxygen, this is also from HNO3, then H2SO4. This sulfur is oxidized into sulfuric acid here, H2SO4. Right, now this formed H2SO4 is again treated with barium chloride, BaCl2. Then students, what you should get here, barium sulfate, BaSO4 as white color precipitate plus 2HCl, hydrochloric acid. Okay, these are the equations. When the sulfuric acid is treated with barium chloride, then barium sulfate, white color precipitate will form. The precipitate of barium sulfate is filtered and washed and dried and weighed. Knowing the mass of the substance taken and the mass of the barium sulfate precipitate formed the percentage of sulfur formed the precipitate. This is the percentage of sulfur can be calculated. How we can do these calculations? Let's see now. In this calculation part, let the mass of the substance taken is W grams and the mass of the barium sulfate precipitate is formed, that is X grams. Now 1 mole of barium sulfate contains 1 gram atoms of sulfur, that is 137 plus 32 plus 64 is equal to 233 grams of barium sulfate contain the sulfur is 32 grams. 233 grams of barium sulfate contains 32 grams of sulfur. Therefore, X grams of barium sulfate, BaSO4, will contain the sulfur is 32 by 233 into X grams. If you do like this, you should get the X grams of barium sulfate will contain how much amount of sulfur. Okay, this is the mass of sulfur present in W grams of the substance. Now students, the percentage of sulfur present in the specific compound is 32X by 233 into 100 by W. Okay, now from this, the percentage of sulfur 32 by 233 into mass of barium sulfate is formed by the mass of the substance taken, mass of substance into 100. By using this, you need to find out the total percentage of sulfur. Here is the question you have, what you are going to solve this, the percentage of sulfur in the specific organic compound. In sulfur estimation, 0.157 grams of an organic compound gave 0.4813 grams of barium sulfate. What is the percentage of sulfur in the compound? Okay, here the mass of the substance we taken, that 0.157 grams. Okay, and the mass of barium sulfate precipitate is formed. Barium sulfate precipitate is 0.4813 grams. Now, what you finalized that 1 mole of barium sulfate is equal to 1 gram atom of sulfur, or 137 plus 32 plus 64, this is from barium sulfate, is equal to 233 grams of barium sulfate is equal to 32 grams of sulfur. That is, it represents that 233 grams of barium sulfate contain the sulfur quantity is 32 grams. Therefore, 0.4813 grams of barium sulfate it contains, the amount of sulfur should be calculated from 32 by 233 into 0.4813 grams. Therefore, the percentage of sulfur in the specific compound is 32 by 233 into this 0.4813 into 100 by 0.157. By doing the calculation, we got the final answer 42.10. This is the final answer. So this is the estimation of sulfur percentage. Okay students, this is about our today's session about estimation of sulfur and estimation of halogens. Both are in Carius method. This is the Carius method diagrammatic representation. In this some examples also we have studied, and what is the calculation part also we have studied. Okay, and what is your opinion, and if you understand this class, what is your view and your complete, if you have any doubt also you can convey in the comment section. Okay, if you understand this class, if you like this class, please subscribe and click the bell icon for my further updates. Thanks for watching.